Hello, I am going to teach you how to use partial quotients box method today to divide. So, box method means we have to set up a box, typically a rectangle, and we can add to it and make it larger if we need to. So the size really doesn't matter too much. But for our problem 9,456 divided by 8, we are going to take our divisor and write it on the outside of our rectangle. Our dividend, the larger number, the number we have to divide up into pieces, will go in the top left corner of our rectangle. Now, the first thing I always tell students to start is by looking at the first digit in our divisor. And we need to ask ourselves, can 8 go into 9? And our answer is yes. So we can actually stop at our 9 and just look at our first digit. Now, 8 can go into 9 one time. Let me get that out of your way. And 1 times 8 is 8. Now, 8 is really far away from 9,456. So I'd ask the students, what do you think that we could do to make this number closer? Now, we could add some zeros as placeholders, and we could make this number 8,000. If we added 3 zeros here, we also need to add 3 zeros up there because 8 times 1,000 is 8,000. Now we're going to find our difference. Our difference is 1,456. So we're going to draw a nice little line here, and we're going to rewrite our difference along the top. Now, we can start by looking at the first number, and I would ask the students, can 8 go into 1? And the answer is no, not easily. So we're going to look at our first two digits. And I would say, how many times can 8 go into 14? Well, we know that 8 times 2 is 16, which is too high. So 8 times 1 would give us 8. Now 8 is really far away from 1,456, so I'd ask them what we could do. We could add some zeros as our placeholders. If I add 2 zeros here, I need to add 2 zeros to the top because 8 times 100 is 800. And now I need to subtract again. Now I need to regroup here. Really, I know that 14 minus 8 is 6. But regrouping is an issue with some of our students. So if you could practice subtraction problems at home, that would be really, really helpful because no matter what method you use with division, you have to be subtracting. So I'm going to draw another line down here, and I'm going to take my difference and I'm going to rewrite it up here. Now, 8 can't go into 6, so we're going to be looking at 65. And I'm going to say to myself, how many times can 8 go into 65 without going over? Or what multiple of 8 will get us closest to 65? Well, 8 times 8 is 64. And I can add 1 0 here and 1 0 here. Subtract. We get 16. Now, even though I've run out of room in my rectangle, 16 is still larger than 8. So I can't be done. I need to just add a section off to the side, and that is totally okay. I'll write my 16 over here, and I'm going to say 8 times what will get me as close as possible to 16? Well, 8 times 2 is 16. Subtract, I get 0, which is awesome. It means we have no remainder. And I'm going to rewrite all my partial quotients down here. And I always encourage my students to rewrite it, make sure they're lining up all their place values, because this, believe it or not, is where sometimes we make most of our mistakes. So, 9,456 divided by 8 is 1,182. Now, there will be times where the students are going to be given a problem that is already set up like this. Now with this, they don't have as much freedom of picking what multiples they think would be closest because they have some preset boxes already. Oh, hold on one second. Okay, we're back. So, we always start by looking at the first one. And I say can 9 go into 4? And it can't. So we're going to look at our first two digits and we'll ask ourselves what multiple of 9 will get us as close as possible to 43. Well, we know that 9 times 5 is 45, which would be a little too high. So we're going to go with 9 times 4, which is 36. Now, I love to underline these numbers also because it helps me remember where I need to write my multiples underneath so I'm lining everything up correctly. And I'll always ask the students, well, 36 is really far away from 4,306. What can we do? We can add some placeholders as zeros. And if we add 2 zeros here, we need to add 2 zeros up here because 9 times 400 would be 3,600. I will then subtract. I have to regroup. Okay, now take my difference. I'm going to rewrite it up in the box up here. And I'm going to ask myself, can 9 go into 7? Not easily, so we're going to go 70. Can 9 go into 70? Well, 9 times 7 is 63. 9 times 8 is 72, so that would be too high. So I'm going to put my 7 up there. 9 times 7 is 63. Add my 0. Add my 0. 6 minus 0 is 6. I can't take 3 away from 0, so I need to regroup, make that a 6. 10 minus 7 is, 10 minus 3 is 7. 6 minus 6 is 0. I'm going to take the 76 and rewrite it up top. Now, what multiple of 9 can get me as close as possible to 76? This is where it is more similar to the standard algorithm when they have the preset boxes because they have to pick the multiples that are closest to that number. Whereas if they're creating their own boxes, they could just keep expanding. So 9 times 8 is 72. 6 minus 2 is 4. 7 minus 7 is 0. Is 4 smaller than 9? Yes, it is. So I'm going to circle it. And that is going to become my remainder. And then all I have to do is add up my partial quotients up here. So we have 478. So 4,306 divided by 9 is 478, remainder 4.